Hello, everybody. Thank you for joining me today. Hope you guys are all having a great time at the Virtual World Ag Expo. Hope to see all of you guys in person soon. My name is Daryl Hadlick, and I'm the Northern Central Valley Sales Manager for WiseCon. And this is our presentation on how irrigation automation and telemetry helps save water on almonds. If you have any questions, my contact info will be on the ending slides. Feel free to reach out. I'll also be answering questions live here. Thank you very much. So a little background about WiseCon. We're an ag tech company that specializes in automated irrigation systems. We were founded in 2006. We are from Chile. That's where a bulk of our business is done, but we came over to California in 2015. Since then, we have equipment across 250,000 acres, over 6,500 nodes deployed. I think that number is now north of 7,500 company-wide. We also have over 20 distributors in the United States. That number keeps growing. We also have 15 alone in California. Right now, we've got a little over 1,500 users. I think we're close to 2,000 now in 5 different countries, being Peru, Argentina, Chile, Mexico, and the US. We have both our support and a logistics warehouse all in Fresno, as well as Chile. Another thing that we've kind of been highlighting recently too, with all these different ag tech companies coming out and providing different services to growers, is having a bidirectional API. So we've got more than 5 API integrations done in the state of California, and that's constantly expanding. Here's just a quick snapshot. All these little droplets and dots that you can see here are current projects that we've got throughout the states. Once the season's over, we're going to take an updated screenshot of all the projects that were installed, and you'll see a lot more being done in the Pacific Northwest, so Washington, Oregon, Idaho, as well as the Southeast. We have sales representatives throughout the United States. Our bread and butter is the automation side, so the online irrigation management system. We act as the remote control for the farm. That's kind of how we're branding everything to say, turning it off and on. That's the bread and butter of our automation. Just a quick at a glance, how it works is either from your app, from a mobile desktop, you're scheduling irrigations, that's being sent to the cloud. We use the Amazon Web Services. From there, it goes out to our cellular unit, which is a gateway in the field. So using either Verizon or AT&T, that then will send data back and forth to the cloud that appears, on the screen. So that gateway is sending out commands to all of the nodes. So if they have to open a valve, turn on a pump, everything's pre-programmed on the node so that when it comes time for irrigation, no matter if it lost cell signal, it's still going to happen. The nodes have an internal brain that are kind of taking control and sending data back to the gateway. So all of this communication is happening on a 900 megahertz radio frequency, and we've actually patented this type of hydraulic logic, is how we're labeling it. So all the nodes in the field are talking to each other, sending it to the gateway. It's coming back on your phone every 15 minutes, or if you have a bigger data plan, you can get it down to the minute. So all that data is coming to your phone, to the office, to your home in real time. Simple stuff is pump start and stop, wireless valve operation in the field. We come onto projects a lot that either need to be retrofitted or they're built from design from the ground up with automation. Weather station monitoring, alerts and alarms. Same thing with soil moisture probes, looking at soil trends, looking at how long you irrigated and how it's moving throughout the soil. Lastly, all from a remote location. So you're in the field on your phone, you're at home on your phone, or a desktop or tablet. We're composed of our hardware and our software. Our hardware, I'll talk a little bit about that right now, just to cover the basics. The M1 is going to be our soil monitoring node, so it's just like a data logger. It can read soil moisture probes, pressure switches, pressure transducers, weather stations, dendrometers, all that type of stuff. And then we come over to the C1, which is actually our full pump filter station controlling node. That unit alone can operate 5 different pump systems. With expansion modules, it can also control more than 50 valves. So it's a pretty expandable unit. And then our flagship node, the node that you'll most likely see in the field, is going to be the X1. So that's our monitoring and control node. That unit alone can be monitoring pressure switches or reading a flow meter, all while actuating stuff in the field. So opening and closing valves, turning off and on pumps, all off one unit. A little bit about WiseCon's software. Covered it a little bit briefly, but this is just kind of a way it works. So either a third-party platform where I talked about all these ag tech companies that are coming out and providing a different service to the growers. We're now throwing out our API, so it's a bidirectional API. People can use it 3 different ways. We've got the app, our free version through that third-party platform, all going through the WiseCon server out into the field. And like I had stated previously, everything's talking to each other, going back to the gateway, and then getting data uploaded onto your screen. You can see here in the little graphic, at the filter station, at the first station, at valves or at different soil probes. I'll go over a little bit about our web page. So this is just a quick snapshot. We've got a node layout. So in the field, growers can kind of map out, or the dealers, our distributors who we work through, are actually going to help us map out the field. So, if it's going to be VRI or anything like that, we're using a Google Earth KMZ file, and we're kind of just setting polygons, putting pinpoint locations of the node. And from this right here, actually, the grower is able to click on it, view the GPS location where the node is, as well as see which blocks are running, all in real time, uploaded onto their platform. It's really easy to schedule. We do it 3 different ways. So we do it by duration. So if you just need to throw on a 12-hour set, you pick your start time, pick the duration, throw in the amount of hours you'd like to see, and then based on the flow meter and the acreage, you can see how many inches you're going to be putting on. The date and time, so you can also click on a calendar icon. You click there and you can have it customizable to exact times and exact moments that the irrigation needs to start and stop. And then we've got volumetric irrigation, which I'll get into a little bit later as well, because that's part of this presentation. But making sure that everything's accurate in the field, like your flow meter readings, your acreage, and then the crop type, if you're going to be comparing crop coefficients or using that data with ET to calculate irrigation, you're going to want to make sure that's accurate as well. The last way we do it with irrigation scheduling is by creating templates and programs. So what the program is doing is setting a template for an amount of time. So the template is showing you what's happening throughout the day. The program is just telling you this is how many days this template is going to actuate. So growers can come in on a Sunday night or Monday morning, set their irrigations, and then print out a schedule and let it go from there. Post the schedule up in the shop, and the irrigator can kind of take a look at what's going on, what blocks are going to be running, and what times they should shut off. Here's just a daily view. So from midnight all the way to 11:59 p.m. the next day, all of our stuff is labeled in military time. All right, there we've got the ability to enable peak hours, look at a week's view, at a day's view. So we're looking at today. I can see all the different irrigations, which are those highlighted blue blocks. And then everything underneath it is going to be what actually happened in the field. And I don't know if you guys can see that super well, but they are green below there. So that means that they had a fertilizer injection included within that irrigation, which is another thing that we do help growers with. We can control different fertilizer pumps. You can schedule multiple fertilizer injections within a time span of an irrigation. This is that weekly view, so same exact ranch. Now we looked at the day, now we're looking at the entire week. So looking at the schedule throughout that entire time. And I'll talk a little bit more later about the flexibility, but you can see some days in here or some irrigations in here are missing, and there may be a purpose to that. I'll talk about that a little bit later. A lot of the things that we like to, focus on besides, just the start and stop is making sure that everything's operating in the field and that you're getting accurate reports of how much water you're actually using throughout the season. So the black blocks here, we're seeing, within a week span, how much water did I use, calculating that by, the acre feet. You can also see the flow meter coinciding with those blocks. And then we've got the red line, which is tracking the accumulated volume, so the accumulated acre feet throughout that growing season. Do a little bit on the reporting side as well. So growers have the ability to, if they were applying for any type of sweep grant or anything, or where they needed to show proof of automation or proof of the projects that they've had, they can come here, they can see their total events, how many times they've ran, pick a specific date. So I've got, a couple months here. Total volume, so total acre feet used, the total run time. Flushing is a capability we're coming out with later. And you can compare those statistics to what was actually scheduled. So you hit a certain amount of the irrigations that you scheduled. Looks like 100%. There was no actual operational problems in the field, whereas an irrigation failed, 99.9% accurate. We also have our mobile app. So this is something new that we've been working on for the last few years, is getting this really dialed in and user friendly. Finally got to the point last year where we had the latest update, and we've got guys who are 60+ years old who are in the field irrigating based off of the app, as well as guys who are non-English speaking, they're all speaking Spanish only. They can use the app as well. Same thing with the desktop and the app, they can either be in Spanish or in English. You can look at what's running on your farm, the historical data of what ran in the past. If you clicked on the irrigation that was live, you can see instant flow rates, you can see your pressure before and after the filters, as well as your soil analysis, irrigation analysis, and a farm map. So you're looking at the little water droplet icons of what's happening in the field, and you can correlate that with what's coming up or what was executed in the past. You've got a lot of different filters there as well to look at, and you can look at your soil moisture blocks, your irrigation blocks. And the same thing with the desktop. If you click on a node, you can get the GPS location, and on your phone, there should be a link provided that'll directly connect to your Google Maps or Apple Maps link, or Apple Maps application. So talking about those API integrations, here's just this little summary of all of them that we've done. So all of these guys can be providing different services, whether it's weather services, irrigation recommendations, water budget balancing, energy monitoring. All of those are going to be tied in. So there's a lot of different avenues that we can take to work with other companies so that we can find and close the loop for the grower when it comes to irrigation. So I've got the recommendation, or I've got this amount of data. Now how can I actuate that and translate that into action in the field? That's where we come in. We do the hardware in the field that's opening and actuating, servicing the grower's needs. So I think it was David Dole from the Almond Doctor who had talked about, the first step to having any type of water saving or looking at, efficiency is planning for efficiency and having a good irrigation strategy for efficient water management. So that's kind of what I'll talk about a little bit first. Per variety irrigation, so just a simple little thing that I'm showing you here on the right. I don't know if you can see that very well, but we're looking at the different locations of where the main lines are going to be and where other lines are going to be throughout the field to deliver water to each variety. So you could be harvesting one, and if you have subsurface drip on another row, that's a different variety or a different nonpareil or a pollinator. You can be irrigating and harvesting at the same exact time. All right, same exact thing. So we're implementing this per variety irrigation, making sure that we're scheduling dependent on what that tree or what that variety needs. We want to make sure it's actually working. We want to make sure that it's getting the right amount of flow to it or having the right amount of pressure within the line. So another telemetry aspect of that is throwing, like a pressure transducer, which you can see here on the right. I can see PSI that's on the blocks there, or on the valves there, and you can see it attached into the line there. We're looking at different pressures, making sure everything's going well in the field, and that when I'm actuating those irrigations, everything's kicking on. You can see that they're doing, skipping every other day. Another one, this was a pretty recent project. It actually was over the span of a few years. So these guys had a lot of operational issues in the field. I believe it was starting with, they would open 4 blocks, they'd have 4 blocks running, but then the irrigator would have to go open the next 4 blocks. So the pump is ramping, or the VFD is ramping up to get pressure down there, and they're having a lot of, pressure problems with delivering water throughout the field efficiently. And then he's closing another 4 blocks in the last time. So now the pressure is constantly changing. So to avoid that, implemented a different system. Here's just a little snapshot what it looks like in the field. Little demonstration of the install. And now we have the valve sequential operation and how it was actually actuated and scheduled. So the red markers kind of highlighting, if you can see that, where they scheduled 4 blocks to open, or 4 valves to open. They've got them all running at the same exact time. And then one closes, so the one on top is closing, and then this one opens up. So now they're maintaining, by a 1 minute or so, that there's still going to be 4 valves open. One's clicking off, one's clicking right back on. One clicks off, one clicks on. So that way we're maintaining that pressure and making sure we're getting the irrigation, the water flow from point A to point B as fast as we can and efficient as we can. These are some of the results that we got from using another API, a company that we share APIs with. There are a few other companies that were in on this project. But you can just see here how the uniformity and vigor have changed throughout the years. So it started off, you can definitely see how it's opening 4 valves and then having to go and close all this stuff, but the pressure's not getting there. The water's not getting to the end of the row. So with the sequential operation, after 1 year, you're able to see quite a significant difference. And the next year, it's like night and day from the first. Then we're going to talk about VRI. So this is a project out in Chico. So we've got different soil types. I mean, even using Google Earth, you can just see, where they irrigated last and what's currently dry. There we had, people come out and we just took a backhoe and we're able to show the difference in soil, how different it was from one side to the other just within a couple feet. Some things to consider with VRI, I guess would say, so here's just an example. You're cutting off the drip line so you can irrigate different spaces according to, the tree requirements, because you may be setting water on a certain block, but then on a sandy loam, but then, on a hard pan clay, then down the row, it's going to be different requirement. So some things to take into consideration. It's not exactly the cheapest method, so it is an investment. It is a little more costly, but for the perennial crops is what I've seen the most use of VRI. So it's site-specific irrigation. So like I was said before, to start this whole efficiency thing off is making sure that, we're getting the irrigation, we're getting flow to the right places, point A to point B, the fastest, but also, gearing our irrigation system towards the needs of the crop or needs of that type of soil. They have different holding capacities, and you can use, soil mapping, EC testing, and different soil tests in order to implement this. And the structure of VRI is technically making smaller sets to reach better distribution. So instead of running these huge blocks, you may be either underwatering or overwatering depending on the soil type. So creating these smaller sets, cutting off the drip line and making the automation, adaptable for the grower. Now we'll talk a little bit about the different technologies and methods. So technologies that can help improve the irrigation efficiency. Like today, we'll talk about a lot of telemetry, a lot of automation and control. And then over the years, there's been a lot of imagery and AI and data analytics. So satellite, like we saw before in that last case study, you're using an imagery and an NDVI filter to, calculate or observe what's going on in the field, where your irrigation requirement is. And then you've got the data analytics side, which some companies, these kind of are a pick and play. So they have an irrigation recommendation service. Some will, like Phytech, will tie into either the soil probe, the weather sensor, the plant sensors, and then based on a dendrometer, they're either measuring like the plant caliper, so how much the plant or the fruit itself is growing, or the tree trunk size. So, if it's expanding, contracting. And then also with the irrigation recommendation service, there are companies who are using imagery or satellite. So you're getting satellite to look at, the evapotranspiration and then giving an irrigation recommendation based on that. And the automation and control is where we come in, but we tie into all these different companies with our API. Some examples right here. Hope that's big enough for you guys, but like a couple Centec probes in the field, you can just see the different moisture out in the field right there on the exposed probes. Pretty simple installs. One thing to make sure and keep in mind is that they're placed correctly. There have been, multiple projects where I've walked out to, it looks like a probe is reading dry, but it's because it's nowhere near an emitter or even the tree root zone. So we want to make sure that when we go and have these installed, that they're, by an emitter next to the tree where it's important for the tree to be, absorbing that water, consuming that water so that we can track trends. Another picture looking at the tree trunk dendrometer. So, expanding, contracting. That's how that company I talked about earlier, Phytech was using their irrigation recommendation service based on stuff like plant sensors, weather, and different soil moisture probes. So, automation, telemetry, it's all great stuff and it's all, been proven to help growers. But the thing about that is ensuring that from the start, we get a good jump on it and we make sure that we don't just set it there and leave it. We've been really active with our growers to make sure that everything is implemented correctly and that you're getting what you got, what you put into it, basically. So how can you truth that data? Here's just some examples. The pressure switch and flow. So we can schedule an irrigation. I mean, we're just going to use us for example, but using the automation, schedule an irrigation, everything runs, it tells you on your phone, irrigation started, irrigation stopped. But one way to truth that is by looking at flow, and we can also compare it with a pressure switch. So if there's more than 10 PSI in the line, it's going to show you that the valve is open or that there's water running through the main line, the drip line, and then comparing that with, the flow meter. So I can see, okay, so everything actuated in the field. Not only do I know that, but now I've even got, accurate reporting on how many acre feet I just used or how many inches that I just irrigated. Another thing that, is used widely, has been for years, probably will be for forever. And we actually do recommend is, if you put a soil probe in, you can take a backhoe to it, take the little probe there, feel it around in your hand and make sure that moisture is to the level that you're seeing on the screen. If it's saying it's heavily saturated, but you go out there and, the probe may be directly under the emitter and the drip line has a break, so it's just constant water flowing to it, but near the tree trunk or the root zone, it's not of that consistency. So it's good to go out there, hand truth it, make sure everything, looks good in the field so that way, you go to sleep comfortable at night knowing what you put in is working and that everything's going fine. Same thing with the pressure chambers or the pressure bombs, looking at the leaves and making sure that moisture is at an adequate level and is comparable with the readings that you're getting, on your laptop or on your phone. You want to make sure the data is accurate. So I talked about this earlier, making sure that our growers get the right crop type. If they're using, an agronomist that's having them use ET or the crop coefficient to calculate irrigation recommendations. But the same thing goes with the flow and the amount of acreage they have. So, if they have a flow rate of 1,500 gallons a minute, but they missed a number and they only put there was 10 acres there instead of 100, it's going to be significantly different. Drop control makes an internal calculation for you guys. So to make sure, we're getting the right amount of gallons. Here we can see we had an hour and 1 minute irrigation. It gives you the correct flow average, and then it gives you, we planned based on the flow to have 104,000 gallons out. We ended up getting 104,000 gallons out with a difference of, a couple hundred gallons. So it gives you a volumetric difference. What I've seen happen, especially with this type of telemetry, is, we'll put a reading into a flow meter and you'll think, okay, I'm supposed to get like 1,000 gallons a minute. But then our sensor may actually pick up like 500, 600, 700, it could be a little different. So that's where this volume difference kind of comes into play and gives growers a good number to go off of to say, oh shoot, maybe something's wrong. My pump isn't efficiently operating to where it's, kicking up enough flow, or the flow meter is just reading wrong. So this is a row crops example. So these guys are out of, I believe, the Dos Palace area. But they've got cotton and tomatoes, and using, they had the irrigation recommendations in inches based on the crop coefficient for both the cotton and the tomatoes from their agronomists. So they were able to plan out a program. Weekly, they would come in on a Monday morning and just set, however long they needed to irrigate to achieve those amount of inches. Right here, you can see that there was a little bit of a difference. So, how did they get to this point? Well, they originally had it to where they could schedule it every single day, but using an automation service, that type of technology gives you the flexibility to, plug and play or delete things. So they just came in here and deleted certain items. Another thing that's interesting about this is you can see there's this really tiny gap here. The grower knows based on his flow rates, based on, the emitters and what he can put out. He was able to schedule this though, right in between this time, because this is a bigger block, so he can't be running, everything at once. But back here, these are grouped a little bit smaller, so he was able to run these two at the same time. And all that I'm pointing out there is the flexibility of the system. You're able to schedule what you want when you want for the right amount of time. So they're irrigating volumetrically using that correct crop type. So they're basing off the crop coefficient that they're calculating internally. We're not calculating the crop coefficient for you. You can enter it into drop control as like a reference, but that would be something that the agronomist or is done internally. And then that site-specific irrigation definitely reduces the amount of unnecessary water applied. So that's, even going back to the VRI case that I had just used. You're being specific with where you're putting on water. That's, specific to that soil type, that crop need, or the need of the entire operation. Now we'll get into the irrigation strategies for water conservation. So now we're going more into, we started off with, okay, we can save water. Telemetry and automation will help you do that. But first we need to start off with efficiencies. Make sure that, the place that we're implementing the technology on is already set up for success. So irrigation strategies for water conservation. Right here, this is a case that we use pretty frequently because it was pretty amazing to watch. But you've got 170 acres out in Madeira. This guy actually lost a well in the middle of the season. The middle of irrigation season went from being used to 1,000 gallons a minute to like 500 gallons a minute. All the lines are buried 3 to 4 inches, so subsurface irrigation. And kind of going back to the efficiency part, that also will play a factor. With the flood, it could be 65 to 75% efficient, whereas subsurface, you have an efficiency application rate of about 85% to 95%. So this is what his irrigations look like from midnight, starting the pump right at midnight and ending his last irrigation at 11:59 p.m. If you can count that top one, it's 1, 2, 3, 4. It looks like about 9 irrigations, 9 pulse irrigations. So maybe not on the energy side of things, but definitely on the water savings. You're keeping water where you need it, and you lost a well, you don't really have a whole lot of reserves to fall back on. You can definitely see also there might be some age ranges. I know that we had some different plantings that are a little bit older and a little bit younger, so the plant requirements are different. Like I said before, it's a very intense irrigation method because you're constantly having to monitor that soil moisture level. You can see here on a daily basis, there's no real break. There's constantly irrigating, constantly keeping water on that ranch, and you're looking at weather data to help you plan, especially the temperature trends, and you're relying on like a visual inspection of the trees. So you want to make sure there's no lines broken. I mean, you're still gonna usually go to the field and just check on that type of stuff, but they've also now implemented pressure transducers where if the pressure drops significantly on the drip line, you can definitely tell that there may be a broken line in the field, can get that fixed and go from where you need. And that quote right down there kind of sums it up too. With what I said earlier, there's no water reserve and you're constantly paying close attention. We actually had UCA&R and the Almond Board come out to that field in 2018. They had heard about the story, and Tom is usually in contact with them. His name's Tom Rogers. Went from irrigating, to 1,000 gallons a minute to 500 to 600 gallons. He ended up saving 30% on his water while still averaging about 3,000 pounds per acre. And it definitely saved him on time because, using that operational feedback, so knowing on the screen that stuff is actuating in the field, using those pressure switches, using those pressure transducers, it's saving him a lot of time. So he's able to go in one day, plan his irrigations out for the next couple weeks or the month, and then set it and let it go. And now he has a schedule not only online, but we give you a printable version of how you can track that. So they're basically validating that irrigation strategy. And they had even said, this feels like the University of Pulse Irrigation for that guy specifically. This is another case that we've had. This is out in Lemoore on 850 acres of pistachios. So he went from running, once a week or putting on those super long sets of 48 hours, 72 hours, 24 hours of irrigation, now going to twice a day. The thing is, we went into it with, okay, I really want the automation, not only because it's going to save me time and labor, but I want to see if it's actually going to save me some water. And it did. It ended up saving him 15% in water savings in one season. And between seasons 2 and 3, we even saw a 38% production increase. That was on his off year for pistachios. So he has his on, his off, on, off. And then he still averaged over 3,000 pounds. I think it was, jumped from 900,000 to, 2.3 million. It was pretty insane. This is another case where we saw probably the most significant amount of water savings. So this is by a farm management company out in Bakersfield. They had about 175 acres. Traditionally, they were just running them either north or south, east or west blocks. Using telemetry from a couple different companies. So they're using telemetry from one who's providing them the irrigation recommendation, then using our stuff or some type of automation system, they're able to actuate that in the field. Here's just a little background of, the project details. So the crop type, both were first leaf. So this is a first leaf, and then the project we compared it to for the traditional method was also a first leaf. One pump of EFD, field valves, and single line drip with fan jets. Right off the bat, we were seeing some pretty crazy results. So when we got into the office in 2019, you could see the difference. My screen kind of went out there. There we go. We can see that he applied, 30 to 33 inches, whereas in 2019, with the automation and telemetry, it was 20 total inches. 27 to 28 millimeters of growth. This same exact growth with both seasons, just the only difference was pump and valve automation and using that irrigation and telemetry. So basically started irrigating right off of the soil profile. Watching those trends, wasn't pulse irrigating where he's constantly having to check that daily to make sure his water's getting to the right depth, but it's still, an every other day, every 2-day type of thing where they're able to. So saved approximately 1 acre foot of water per acre, and this is also from their source. They had actually done all of the calculations and gave the data to us. We verified it then in our system, and yeah, 80 acre feet total was, over 26 million US gallons of water that these guys saved in one season. So some reasons to consider ag tech, or trends that are coming up now that have been recent, and we have all these new companies coming out, like I said before, providing a service or giving you a water budget balance. All these are definitely for reasons, and those reasons are conservation. One big thing is that's coming out that a lot of us, I mean, if you're in the irrigation industry, especially in California, you've definitely heard of SGMA. There's no one that hasn't heard of SGMA. Implemented back in 2014, but originally established to manage all groundwater resources, so basins, sub-basins. I think there was over 450 basins that they were looking at. Groundwater sustainability agencies were formed to manage their local basins. So for example, one here would be the Henry Miller Water District, but they are an agency, and then you all came together and submitted a GSP, a groundwater sustainability plan. Those were submitted back in January of 2020, and looking through, I haven't seen any that have determined to be, illegitimate, or they said that anything was wrong. So I think we're still waiting on the data from that. But if you need to, you can type in SGMA and look in the portal, look at the Department of Water Resources, because DWR will take control of certain areas if either you didn't, form an agency, or your GSP was turned down. Currently, in this right here from DWR, they have over 35,000 wells. They have data for all of them. Something to watch for that, I mean, definitely going to have some type of effects. So high pumping or at-risk areas definitely face a potential decrease. I was listening to a lot of podcasts, and a lot of going to all of these SGMA seminars that they were holding throughout the Central Valley. Some are saying that it's going to decrease up to an acre foot an acre to 1 acre foot of water an acre or less of pumping. I mean, that's crazy when guys, if you're in the Merced to Lodi area, you're used to getting 3 to 4 acre feet to the acre. You may be fine just because you have more access to surface water and groundwater services, but in the South Valley, it may be a little bit harder. It's definitely going to have an effect on the supply of product. We're a $50 billion industry here in California. I think we supply alone in the San Joaquin Valley, 85 to 75% of the world's almonds. So an estimated 500,000 acres are actually projected to go fallow with the implementation over 20 years. So you're definitely going to have to be monitoring your water, making sure you have an accurate water budget. So there are a lot of companies out there right now, especially one we work with closely. If you need any more information on that, you can definitely contact me after this. But I just wanted to put this here for you guys, just to give you a basic update, and if anybody's new to it, you have automation information there, and then some other benefits. This is a screenshot from our website, but one thing to consider as well with the other benefits of automation, it's not we're trying to convert everyone to start pulse irrigating or start adopting these VRI methods. It's everything's different for every other operation. But some of the other stuff that we've seen with automation systems include energy savings. So one way that people are saving energy is by doing off-peak irrigation scheduling. So right there, you have the option to disable or enable your peak hours. Over the weekend, if you don't really care, then it's fine. You can schedule over them, and the system overrides that. It won't tell you that you're irrigating in a peak hour over the weekend, but during the week, you're definitely going to be able to see, where my irrigations are. Do I want to avoid this time? And the flexibility of automation is you don't have to have a guy there at 9 p.m. at night, kicking on a pump, and then you just let it run throughout the night. Now you can plan out your irrigations, set this ahead of time, and before you schedule into peak, you're actually going to get an alert. Same thing, and that kind of plays into the labor savings of things. So you can run irrigations whenever you really need with the operational feedback. So you're getting alerts directly to your phone with either a pressure reading saying something turned on, or you can see what's happening in the field, like based on soil moisture, all without having to have someone actually physically in the field. And then we've got the time savings that plays direct. All three of them kind of combine together. I've showed like a couple case studies where all of these do play a factor, and definitely it's going to be time. So, within an hour, if I'm given a schedule and I know the grower really well, and I've been doing it for a while, like most growers have, the irrigation schedule, plan out for the next 2 weeks can be done in less than an hour.
Thank you guys so much for attending our seminar today. I hope that you guys all found it very insightful and beneficial with information. If you guys have any questions, please reach out to my email address below, or feel free to give me a call right at my cell phone number. Thank you again, and I hope you enjoy the rest of your virtual conference at the World Ag Expo.